Hello and welcome back. This is Jeffrey, and the topic we're going to be discussing today is domain and range. So in this section, you'll learn to find the domain of the function defined by an equation, finding a domain and range from graphs, and at last, graphing piecewise defined functions. Starting off with finding the domain of a function defined by an equation. So first, let's just note that the idea of domain and range. So we can visualize the domain as an holding area that contains the raw materials for the function machine, and the range as another holding area for the machine's product. So basically, raw materials goes from here, right? That's what you give to the function machine, which domain is the input, so you plug in x as input into the equation, into the function, and then it will gives you the y, or the product, right? The output. Yeah. So we can write the domain and range in interval notation, which uses values within brackets to describe a set of numbers. In interval notation, we use square bracket when the set includes the endpoint and parentheses to indicate that the endpoint is either not included or the interval is unbounded. For example, if a person has $100 to spend, he or she would need to express the interval that is more than 0 and less than or equal to 100 and write parentheses 0, 100 bracket. To find the domain of a function whose equation is provided, oftentimes finding the domain of such functions involves remembering three different forms. First, if a function has no denominator or an odd root, consider whether the domain could be all real numbers. Second, if there is a denominator or the function's equation, exclude values in the domain that force the denominator to be 0. And at last, if there is an even root, consider excluding values that will make the radicand negative. So before we begin, let us review the conventions of interval notation. So the smallest number from the interval is written first. The largest number in the interval is written second, following a comma. And the parentheses are used to signify that an endpoint value is not included, called exclusive. Brackets like this are used to indicate that an endpoint value is included, called inclusive. Here's a cheat sheet to keep in mind. So for x is greater than a, not including a, we use bracket. And it goes on to positive infinity, because as long as it's greater than a, it's okay. And same thing here, it goes to negative infinity and not including a, so we're using the parentheses. For this one, it's x is greater than or equal to a, so we have to use bracket because now a is included as an option. So in that case, we use bracket, and it still goes on to positive infinity. Same thing here, it goes to negative infinity, and we use bracket instead of parentheses. For here, where x is strictly between a and b, we're using parentheses, right? Because x is between a and b, not including a and b, so we're using parentheses. For this one right here, where x is between a and b, to include a, we're using bracket for a because it includes a, and parentheses for b since it's not included. Same thing here, we're including b, so we're using bracket, and not including a, so we're using parentheses. And for the last one, where both a and b are included, and x is in between them, we're using bracket for both. So the second one is finding domain and range from graphs. So just note that domain is usually the x, the horizontal one, and range is usually the y, the vertical one. So take a look at the graph here, right? We got a function in blue that's starting from, in terms of x, start from -5 and keep on going to positive infinity, right? Going up. It's gonna go this way eventually. And for the vertical component of this graph, it's starting off from the bottom here, down here. It's go all the way down, so negative infinity, and it goes up until here, until it reaches +5. And note that here's it's a closed circle instead of the open circle. So the closed circle basically tells us that, well, +5 and -5 are included. So we can observe from the graph that extends horizontally from -5 to the right without bounds. So it's gonna keep going until it reaches positive infinity. So the domain is bracket -5 comma infinity parentheses. The vertical extent of the graph is all range values 5 and below. So the range is negative infinity up till 5, where like you need a bracket because 5 is included. Note that the domain and range are always written from smaller to larger values, or from the left to right for domain and from the bottom to top for range. The last one is graphing piecewise defined functions. So a piecewise function is a function in which more than one formula is used to define the output over different pieces of the domain. So an example of that will be absolute function. So like here's a graph of the absolute value function. We can basically split it into two parts. The right part right here, like having the positive slope, is basically y is equal to x, right? So we can say that for f of x equal to x, if x is greater than or equal to 0. So let's plug in 2x in this example. Since 2 is greater than or equal to 0, we can plug in here. We have to put it in the top equation. So f of 2 will be 2, right? So it's going to be here. And if we use something like -1, we cannot put it here because -1 is not larger or equal to 0. So we have to put it here instead. So if -1 is less than 0, which is true, we plug in -1 here, giving us +1 right here. And this will be our solution for when x is equal to -1. Right? And in real life example of that would be consider a simple tax system in which incomes up to 10K are taxed at 10%, and any additional income is taxed at 20%. The tax on a total income S would be 0.1 times S if S is less than or equal to 10K, and $1,000 plus 0.2 times S minus 10K if S is greater than 10K. That's how the piecewise function works. Right, so how to given a piecewise function, write the formula and identify the domain for each interval. So first of all, identify the intervals for which different rules apply. Second, determine formulas that describe how to calculate an output from an input in each interval. And at last, use braces and if statements to write the function, like here. We use if x is greater than or equal to 0 and if x is less than 0. Piecewise function. So a piecewise function is the function in which more than one formula is used to define the output. Each formula has its own domain, and the domain of the function is union of these smaller domains. We notate this idea like this. F of x is equal to formula 1 if x is in domain 1. It's equal to formula 2 if x is in domain 2. It's equal to formula 3 if x is in domain 3. Alright, so for the absolute value function, it looks like something like this. So for the top function, the domain goes from 0 to positive infinity. And for the bottom function, it goes from anything smaller than 0 to negative infinity. So the domain of the absolute value function is gonna be like real numbers. Because let's take a look at this graph, the graph for absolute value function. It goes from negative infinity, like in terms of domain, it goes from all the way from negative infinity to positive infinity. So it's never stopping. It's right from here, go all the way here, and then keep going on. So the domain of piecewise function is basically every smaller domains for each equation, each function, and you add them up, right? So basically the sum of every single smaller domains. So let's do some practice question. So first of all, find the domain of this function. F of x is equal to x plus 1 over 2 minus x. I'll give you guys like 30 seconds to work on this. Start right now. Alright, so here's the solution. Right, if you take a look at the graph here, it's so basically let's take a look at the denominator first. So 2 minus x is the denominator for this function, and we know that for a function to exist, the denominator of the function couldn't be 0. So x cannot be 2 in that case, because if we plug in 2 on that, the denominator is going to be 0. So x is going to be anything smaller than 2 or anything greater than 2, in which we got the domain for this is, so denominator cannot be 0, yeah, so x cannot be 2, meaning x has to be either greater than or less than 2, but not equal to. So here's the domain for this function. It's going to be parentheses negative infinity, comma 2, parentheses, because 2 is not included, and 2 all the way to positive infinity, right? And we use open circle here because 2 is not included. For the second practice question, find the domain and range of this function. I'll give you guys 30 seconds again, starting from now. Alright, so here's the solution. Here's the graph of the solution. So the range, again, is the vertical one, and domain is the horizontal one. So the domain of f is basically starting from -3, not included, so parentheses, comma, up to 1, included because it's a closed circle. And for the range, it's starting from -4, included, right, -4 up till 0, which is not included because it's like open circle. So right here. For the last practice question, I want you to graph a piecewise function. A museum charges $5 per person for the guided tour with a group of 1 to 9 people, or a fixed $50 fee for a group of 10 or more people. So basically, start with writing the function relating to the number of people and to the cost C, and then you graph it. I'll give you guys a minute to work on this, starting from now. Alright, so here's the graph of the function that should be. So the graph should be looked like this. Museum charges $5 per person for 1 to 9, like for every 1 to 9 people. So, alright, so up till 10, you have to got like C is equal to 5n, because $5 per person. So yeah, for example, if you got 5 people, you times 5 per person. So 5 times 5 is equal to 25. So it's going to be, the cost is going to be 25 right here. But notice that the line became a horizontal line after it reaches 10, because it says right here a fixed $50 fee for a group of 10 or more people. So it's gonna stay the same for every n greater than or equal to 10. It's gonna stop here and go all the way there. Alright, and that's it for today. Thank you for listening.